Oh, hi students. I'm just catching up on some of my favorite projectile motion and oh, looking good. Here's another one. Gorgeous. I don't know if you guys can see that. Let me emphasize this. Let's watch that next one. Oh, there it is.
And then Horace Grant ran the floor well as the Bulls got the next. Instead it's Pippen looking inside for Cartwright, who's got it. Cartwright back to Jordan. Fakes it. Harvey Grant on him now.
Oh, that was a steep one. It went like this.
Fell down, slid back on defense, and still hit it.
Let's see another one. Ooh, gorgeous. Ooh, missed it. Coming down and up and oh, that was a nice one. It went like that.
Harvey Grant on him. Bulls set up the triangle and reverse it. He's wide open at three.
Oh. So hopefully you're starting to see the shape that I'm talking about. I'm talking about a projectile motion, and you can see the shape that it's making. It's a nice curve shape. Oh, that was a good one. Are we gonna get one more? No, that's good. Let's see if I can pause this. So I don't know if you guys were able to see that or not, but the shape that we were talking about there was a quadratic, which is made from the equations like y equals ax squared plus bx plus c. And those are what quadratics are, when they have that exponent of 2 and it creates that parabola shape. And we're going to typically measure these in height versus time, just the way that basketball, you could measure the height above the ground over time, or you could also just look at that visual shape because it's also moving forward over time. And so in that case, when we're looking at that, we're commonly going to refer to x as time, and that's going to be time in seconds. And we will also refer to the y value as the height. And we're going to use feet. Yeah, right? This is America. We like to use feet. And then we'll have, oops, I got to put my x back, time in seconds. And then the starting height, then that's going to be before that projectile shape begins. So as soon as he let go of the ball, that was the starting height, and that's going to be the y-intercept. And that's typically 0, c in standard form. And then when did it reach the maximum height? Oh, maximum is an important keyword. Maximum means vertex. And so we see when. So I answer the question when with time. So we're talking about the x value or the h. And the formula for h is negative b over 2a when we're in standard form. And so when vertex is the x value of the vertex. And then so another common question that they'll ask about a path of a projectile is, what was the maximum height? So again, I see this keyword maximum, and I think vertex. And they say, what was the maximum height? So we want to answer that in feet. And so this is the y value of the vertex, or the k. And we get the k by plug in h to find, oops, it doesn't want me to write there, to find k. And then the last question that they might ask is, when did it land? So when did the projectile, or the projected object land on, where will it land? On the ground. And so at the ground, that's what we call a height of 0. So we're talking about the x-intercept. And if you imagine the projectile, and we'll look at some of those, we're typically only going to have one that works for this, because that starting height is above the ground, and so the other, like if we were to finish the pattern, the projectile would be before that and have a negative answer, and so we can't use a negative amount of time in this case. And the way that we find x-intercepts, those are going to be x comma 0, is with factoring or the quadratic formula. And so that's just some really good information about how to read and understand what is the question about this projectile object really asking me. So let's take a look at this picture, and we're going to use this to guide us in our understanding to make sure that we are kind of getting it. So we see the path of this projectile, the flight of a projectile here. We've got the time in seconds and the height in feet. And we can see that it started right here and it was up in the air for almost 7 seconds. The maximum was reached right around here. And it seems to have a maximum height of about more than 200. I'm going to call this, looks like they're counting by tens, so of about 210. So I'm going to label all the pieces of information that I know here. So this looks to be about 3.2, comma 210. This looks to be about 6.8, comma 0. And then this ordered pair looks to be about 45 as the y value, so 0, comma 45. I might not be reading it that well because I put those big pink dots in the way, but I think we can at least use these as our information. So what was the launch height? Oh, so that would be the starting height. So we're looking for the y value. We're looking for the 0, comma c, the y-intercept. And in this case, it is 45, not 40f, 45 feet, approximately. Sorry, Mr. Mega is barking at the mailman. Then we ask, what was the maximum height? So the maximum height, we're talking about the k value here. And so when I look at the vertex, it's the y value of the vertex, so I would say 210 feet. When did it reach its maximum height? When? Oh, and maximum, we're looking for the h value. So we want to identify what feature are we looking for and then use the appropriate strategies. So of course, here just looking at the picture. So the h value of the vertex is 3.2. So when did it reach its maximum? After 3.2 seconds. All right, when was it 100 feet above the ground? Oh, that's a great question. So 100 feet is a y value. So I'm looking for the y equals 100. So I'm going to go to 100 and I'm just going to go across. I see that it crosses here and I go down to the x value that matches with that. And I would say at 0.7 seconds. And I can see that it will also be 100 feet above the ground again over here at almost exactly 6 seconds. We'll call it 5.9. So in that case, I was given a y value and I would plug it into the equation if there was an equation as the y value. But in this case, I was able to just draw a horizontal line at 100. And when did the projectile land? They're asking me about the x-intercept. And so that was at 6.8 seconds. So very cool. It's very easy to answer these questions based on a picture. Let's take a look at answering these similar types of questions based on an equation. And we've got our first equation here. And we're talking about a baseball. And I wonder if I can move my face. So a baseball is hit following, is hit, and its path is modeled by the equation h of t is equal to negative 16t squared plus 96t plus 4. And so just as like very interesting, this is always negative 16t squared when we're using feet, plus this is the initial velocity. Oh, I forgot the exponent too. Times t, plus this is the original height. So we use that sub-zero to mean like starting or original. V for velocity, h for height. So this is like a cool physics formula, in case you were interested. So, sorry. So it asks us in A, when did the ball reach its maximum height? So we want to say, okay, maximum, that means vertex. And when, we answer that with t, so that means it's the h value that we're looking for. And I find h with the formula, negative b over 2a. When did the ball reach its maximum height? I'm looking for the x value of the vertex, which I call h, not to be confused with the h of t because we're talking about height in this case. And so I'm going to use the equation. So it's going to be negative 96 divided by 2 times a, which is negative 16. And of course, for all of these, since we're talking about a real life application, we're expecting positive numbers, right? We expect the maximum to be above the ground when we're talking about height. So it looks like we're going to get that. I have a negative divided by negative. I'm going to have negative 96 divided by negative 32. Those two negatives cancel out and become positive, and 96 divided by 32 is 3. So this is all they want us to find out. So I would say, and let's answer with a sentence, the baseball reached its max height after 3 seconds. Oh no, I just messed that up. Okay, very cool. And how high in the air did it get? How high? So it sounds like we're talking again about the maximum. And we want to know, we would answer this by a number of feet. And so this is going to be the k value. And so I'm going to plug in that negative, I'm going to plug in the 3 that I got as the h to the equation in the spot for t to calculate the k value. So I'm going to say the h of t, I don't put it in here. I could technically put it in as 3, is equal to negative 16 times 3 squared plus 96 times 3 plus 4. So 3 squared is 9 times negative 16. That's going to be negative 144. 96 times 3, so that's 270. 90 times 3 is 270. 6 times 3 is 18. So it's going to be plus 288 and then plus 4. So I'm showing all my work. I'm plugging in the 3, doing the calculations. I add these together and I get 144 positive plus 4. So the total is 148 feet. So we would say, how high in the air did it get? It got as high as 148 feet. Very nice. Cool. Let's take a look at another example.